Hey y'all, today we're going to find the area of a triangle. Are we going to find the area of a triangle the normal way? No, we are not. We are going to find the area of a triangle in the most galaxy-brained way I could think of, with integration. So here is my triangle. I have a corner at 0, 0. I have a corner at B0, giving me a base of length B. Some distance between 0 and B, I have this value A, and the height of this segment is H, giving my triangle a height of H. We know what the area of this triangle is. It is 1/2 times the length of the base B times the height of the triangle H. 1/2 B times H, or if you prefer, B times H over 2. I'm going to divide this triangle into two pieces defined by these two sides. This side is a segment from line 1. This side is a segment from line 2. I need to find the equation of both lines. Line 1 is going sideways by A and up by H from the point 0, 0. So line 1 has a vertical change of H and a horizontal change of A, making this the slope. Line 2 has a negative slope. The vertical change is negative H. The horizontal change is from here A to here B, making it a change horizontally of B minus A. This is the denominator of the slope. We don't know the y-intercept. For line 1, it was 0, right here. For line 2, it's a mystery. So we're using this symbol that shows us that it's a mystery. But we need to solve that mystery before we can integrate this line. So what can we do? Well, here is the thing we can do. Let's take an x value, which is B, and a y value, which is 0, and substitute those into the equation. My y value is 0. My x value is B. Negative hx over b minus a becomes negative hb over b minus a. Y becomes 0. What's the mysterious y-intercept now? Here is how we find it. hb over b minus a is a number. Here's the negative. I need the same number but positive if I hope to make a 0 Therefore, the mystery intercept is HB over B minus A. That means that my line 2, has the equation y equals negative h x over b minus a plus hb over b minus a. Now we need to set up the integral. To find the area under this line, from x equals 0 to x equals a, I will need to integrate from 0 to a using the equation of line 1. Here it is, the integral from 0 to a of h over a x dx. Then I will need to integrate from a to b of the other line's equation. Here it is, the integral from a to b of negative h over b minus a times x plus hb over b minus a dx. The next step in this kind of definite integral is to find the antiderivative. The antiderivative of a linear term is the constant times x squared over 2, giving me hx squared over 2a. I will evaluate this at a and at 0 and subtract this evaluation from that evaluation. The same happens here. Negative hx squared over 2b minus a plus the antiderivative of this term. hb over b minus a is a constant term. Its antiderivative is linear, having this number as the coefficient. Here it is, hbx over b minus a, evaluated at b and subtracting the evaluated expression at a. So I'm plugging in a, ha squared over 2a minus h times 0 over anything. That makes a 0. When I plug a b into all this, I get negative hb squared over the same denominator, and I get hb times another b, which makes hb squared over the denominator b minus a. I will then multiply 2 on top, 2 on bottom, so that these denominators are the same. Then I will plug a into this expression. Negative ha squared over 2b minus a. And hab, because the order does not matter here, hab over b minus a. Again, I have put the 2 on the numerator and in the denominator to make my denominators the same. Now, let's simplify. ha squared over 2a minus 0 is ha over 2, because the a squared over a becomes a and the 0 disappears. in this term, 2hb squared minus hb squared leaves 1hb squared. Here, 2hab minus ha squared is written simplified. Both of these are still over the same denominator. The first term remains the same. The h is factored out from here and from here and from here. The 2 is factored out from here and from here, written right there. Next, this expression is factored. B squared becomes b and b. A squared becomes minus a and minus a. And negative 2ab appears as negative a times b on the inner pair and b times negative a on the outer pair. After that, b minus a and b minus a cancel out. This is acceptable because earlier we defined a as a number less than b. All this would be different if a was equal to b. And if a was equal to b, we would be dividing by 0, and the cancellation trick would not work, because cancellation really just means that this number divided by the same number gives me 1, and 1 times something is the same thing. HA over 2 remains. HB over 2 is here. H times negative a over 2 is here. And this term minus this term is 0 because those terms are equal. What is left? HB over 2 is left. But the order you multiply does not matter. So HB over 2 is BH over 2, and we have shown what we wanted to show. If you know a little calculus and followed that, I hope that was interesting. If you don't know calculus and couldn't follow that, I hope it was so boring that you were relaxed into a state of drowsiness. Take care, y'all. Bye.